Hi, welcome to Ushendra's engineering tutorials. Two-port networks and Z parameter, evaluating the Z parameters from two-port networks. What is a two-port network? A black box, simply a black box here consisting a pair of input terminals and a pair of output terminals. Is a two-port network. More precisely, considering a transistor in common emitter configuration. What's that common emitter configuration? It's like this one. It's emitter, input is the base and output is collected across the collector, and emitter being common to both input and output. Now this could be considered to be a two-port network where IB is the input current and IC is the output current, VB being the input and VC being the output. So coming back to over here, we have the same representation. More generally we have V1 as a input voltage and I1 due to V1, and we have V2 over this side and I2 due to over that side. Considering V2 as dependent, that gives some sort of parameters. Considering I2 as dependent, that gives some sort of parameters. Now in this case, to evaluate Z parameters, we are considering V1 as a function of I1 and I2. Now this V1 being dependent and voltage being dependent, currents being independent, that gives some parameters, Z parameters. And also V2 can be written as V2 as a function of I1, I2. Guys, beginners are very much stressed to keep all these in mind. Okay, so this one, and how to, this could be put in an equation form like this one, the same extension. This could be written as V1 can be written as Z11 I1 plus Z12 I2. This is equation 1. Let this be equation 1. And on the other hand, V2 can be written as Z21 I1 plus Z22 I2. Guys, Z11, all these four parameters, these are known as network parameters, and to evaluate this one, we need to consider one current being 0. For supposing if this is open, like making I2 equal to 0, going back to this expression, when I2 is 0, we have V1 equal to Z11 I1. I2 is 0, isn't it? That gives us here, that which gives us Z11, which is equal to V1 by I1. This is one of the Z parameter. And guys, input voltage by input current, input impedance, it's impedance, Z parameters, impedance. On the other hand, from the second equation, this is equation 2, from the second equation, when I2 is 0, we have here V2 equal to, when I2 is 0, we have V2 equal to Z21 I1, okay, from which we have second Z parameter, Z21 is equal to V2 by I1. Guys, another Z parameter, important Z parameter, forward transfer impedance, forward transfer, V2 by I1, given the name forward transfer impedance. On the other hand, these are evaluated for I2 equal to 0. When I1 is made 0, coming back to equation 1, now this will be 0 in this case. When I1 is made 0, we have the expression V1 equal to, this becomes 0, so Z21 I2, Z21 I2, and from this we have in a third Z parameter, Z21, which is equal to V1 by I2. Guys, V2 by I1, forward transfer impedance, and V1 by I2, reverse transfer impedance, right? Another third Z parameter over here. When the same I2 is equal to 0, from the second equation we have V2 is equal to, here V2 equal to, this becomes 0, and so we'll be having Z22 I2, from which we have, which implies Z22 will be equal to V2 by I1. V2 by I2. output impedance. Another Z parameter, fourth Z parameter, output voltage by output current, output impedance. Right, this is not all. We have to represent this in a circuit diagram. I mean a layout, a circuit diagram, some sort of representation, circuit represent. Making use of this very black box, we can obtain the circuit representation making use of these equations. This very black box here. So erasing this away. Guys, now this is the layout. Okay, this is the layout. Same, we will be having V1 I1 and V2 I2. Now this one, considering this expression, equation 1, we have V1, this voltage drop is equal to this voltage drop plus this voltage drop. Okay, we have V1 is equal to Z11 I1 plus Z12 I2. We have V1 is equal to this, so we have I1 flowing over here. Okay, so we have this drop, we have I1 over here, so this could be represented like this one. It's this one, Z11 impedance. Now what about this one? This drop is equal to this drop plus this drop here, but we have I2 which is flowing over that side. In the sense, this one, this drop which is Z12 I2, it's a drop depending on I2 which is on the either side. It depends on that one, so this becomes the positive and negative. Now that becomes, this drop is depending on I2, so this is a dependent source, and so we represent in this way. So that's the way we represent a dependent source. On the other hand, we have V2 I2. Coming back to the second equation, we have I2. Now this will be, we have I2 over here. Now this case, this drop is simply Z22. Okay, this one we are done with this one. So what about this one? This is also drop, but which depends upon I1 which is over this side. Once again, this is also a drop. This is also a drop which is a Z21 I1 drop which depends upon I1, so now this is also a dependent source, and so this is the representation. Dependent sources are represented in that manner with a positive and a negative, Now this is the representation. Guys, you have to remember this one. A lot of simplification, a lot of analysis to be made with the help of this one. The representation of these two equations, please. A numerical will help us to understand even more in a better manner, right? So numerical straight away picked from a previous question paper from the university exam point of view. Well, let's consider a network like this one. We have a resistance like this, another resistance like this, here a resistance and a resistance. The same, blindly we can go for that. We have, without a second thought, V1 will be here and I1 will be flowing over here. V2 comes here, over here, and same I2 will be flowing over here blindly. And some values to evaluate the Z transfer. It may be given that let it be 2 ohms, another 2 ohm over here, another 2 ohm over here. Let this be 1 ohm. Okay, sorry, 1 ohm. In the sense, if this is the arrangement, I1 will be flowing like this, I1, and here we have I2 and another current. Let this be I3 flowing over here. Right, writing the drops, this voltage drop is equal to this drop plus this drop. How to write down for that one? So here V1 will be equal to, I1 is flowing through 2 ohm and 3 ohm, so that will be 3 times I1. Okay, and another current I3 is also flowing through I1 in against this I1. I3 also flowing through 1 ohm against I1, so that will be minus I3, 1 times I3. Okay, so this is one, and to this side, making use of this loop, what we have, V2 equal to V2, which is equal to this drop. I mean V2 is equal to this drop, right? So what is that? We have 2 times I2, And watch carefully, even I3 is also flowing along with I2, the same direction with I2. So that will be plus 2 times I3. I2 is flowing in this direction, even I3 is also flowing in this direction. So that's the equation for this loop. What about the third loop? Here, this loop. From this loop, I3 is flowing, all the drops is equal to 0 according to KVL, isn't it? All the drops are equal to 0 in the sense I3 is flowing to 2 ohm and 1 ohm. That will be 5 times I3, and I1 is against I3, so that will be minus I1, and I2 is along with I3, so that's plus 2 times I2, which is equal to 0. Now this is the expression for I3. We have I3 is equal to, I3 will be equal to, it's negative, that will be positive, I1 upon 5 straight away, and it's positive, that becomes negative. Okay, so negative, it's 2 times I2 by 5. I3 expression for I3. Now plugging in this I3 over here, and in this expression we can evaluate the values of Z, all those 4 Z parameters. We have V1 is equal to, here it's V1 is equal to 3 times I1 minus of plugging in straight away this value over here, it's 1/5 of I1 minus 2 times I2 by 5, and this is the case, right? So this will give us 3 times I1 minus 1/5 of I1 plus 2 times I2 by 5, isn't it? So simplifying this one, guys, for I1 we have simply plus 2 times I2 by 5 as it is. Now this will be, it's 14 I1 times upon 5. Check this one. Yeah, do it. Now evaluating for V2, we have V2 equal to 2 times I2 as it is plus 2 times I3 from here. It's I3 should be plugged in with this one. It's 5 minus of 2 times I2 upon 5, isn't it? So taking out this one, it will be simply 2 times I1 upon 5 plus 2 times I2 minus 4 times I2 upon 5, guys. So this will be final V2 will be 2 times I1 upon 5, and this should be plus, guys, 5 times, right, over here, and 10 minus 4, that's 6 times I2. Guys, this is the final expression. Now we have expression for V2, and now that we have expression for V1, comparing this with the standard expressions, we can go for the 4 impedance parameters which we are in search of here. V1, right? So again, from the beginning, what we had, V1 equal to Z11 I1 plus Z12 I2, isn't it? In that case, this one here, this I1 is, it's, now this one will be our Z11, and this one will be 2 by 5 will be our Z12. And over here, comparing this with the standard equation, we have V2 equal to Z21 I1 plus Z22 I2, isn't it? In that case, here 2 by 5 will be our Z21 and 6 by 5 will be our Z22. So these are the 4 Z parameters. This happens always in whatever circuit you come across, the same procedure. You have to reduce the entire circuit equation to its standard equation and then compare with the standard equation. Then another example, let's have a network like this one with 2 resistors like this over here. Let it be 8 ohm with a 5 ohm over here. Guys, let's make the circuit even more complicated here. Let Ix be flowing over here. Let's say some Ix is flowing over here. Let's introduce a dependent current here. Let this be half of Ix. Okay. Now here we have, as usual, V1 and I1, V2 and I2 over here, guys. So that simplification to evaluate the 4Z transform. How that one? Prerequisites, what can be extracted from the circuit? It's guys, I1 is flowing over here. It's I1, and no doubt I2 here, I2, and our I3 in the circuit will be flowing in this direction. Okay, so in that case, check this 5 ohm loop, Ix, which is equal to, guys, Ix will be equal to what current is flowing? It's I2, and I3 also is flowing in this direction only, so that will be plus I3. This is how we make use of this one. And come on to this one, Ix, half of Ix, and so it's dependent. Okay, Ix is flowing and Ix half of Ix is equal to, guys, I1 is in the same direction, so it's I1, and I3 is against this I of this one, against, so that's minus I3. Okay, so from which we have Ix is equal to 2 times I1 minus 2 times I3, isn't it? So this is 1, and even that side we have Ix, so these two will be equal, in the sense I2 plus I3 will be equal. Okay, so in that case we have simplifying for I3, it's negative 2, positive 2 going that side, so that will be 3 times I3. Okay, and it's 2 times I1, it's a positive, it's a minus I2 over here, and finally our expression for I3 will be, here it's I3 will be equal to 2/3 of I1 minus 1/3 of I2. Guys, this one we'll have to make use of this one, this I3, because we want the entire expressions in terms of I1 and I2. So we come across I3, we'll plug in the value of I3 to simplify that for I1 and I2. So from here, what do we have? From the super mesh, they call it super mesh. From this one, this is a current source, no drop over here. For V1 from this point over here, this one, this isn't a drop, it's a current source, so that isn't a drop. We have to consider the drop from this point to this point. So how to write down that one? V1 will be equal to, I3 is flowing from this point to this point, so 8 plus 5, 13 times I3, plus even I2 is flowing in this direction, so 5 times I2. Guys, 13 times I3 from here, it's 2/3 of I1 minus 1/3 of I2, and we have 5 times I2 as it is. Okay, so this will be 26 times I1 upon 3 minus this one, 13 times I2 by 3 plus 5 times I2. Guys, simplifying this one, final V1 equal to 26 by 3 times I1 plus this one, simplifying this one, it should be 2/3 of I2. Check, it's 3, 15 minus 13, that will be correct. This is the expression for V1. On the other hand, what to do with V2? V2 is equal to this voltage drop, so it's a 5 times I2, 5 times I2 plus even I3 is in the same direction, so 5 times plus 5 times I3, and 5 times I2 as it is plus 5 times I3 from here, because the entire expression we need in terms of I1 and I2, right? So we don't need that I3, that should be plugged in with this one. So it's 2/3 of I1 minus 1/3 of I2. Guys, simplifying for V2, we have V2 equal to 5 times I2 plus 10 times I1 upon 3, right? And here it's minus 5 times I2 upon 3. So here, simplifying this one, we'll be having 10 times I1 upon 3 plus 10 times I2 upon 3. Check, it's 3 over here. 15 minus 5, that's 10. Yeah, correct. This is the expression, this is the equation we want for V2. Now comparing this one with the standard equations, we have now this one. This will be our Z11 from V1, and this will be our Z12, and this one our Z21, and this one it's our Z22. More precisely, that for Z parameters, Z11 it's a 26 by 3, Z12 it's a 2 by 3, and 10 by 3 it's a 10 by 3. Guys, 4 Z parameters, the circuit with the dependent source. Hope you understood the analysis. If you got it, support me with your valuable share and subscription. Thank you for watching.